is the segment lengths video. When finding segment lengths on a number line, the length of a segment is a positive real number. You can use the number line to find the length by counting. So it is a positive real number. When you're talking about length, you have to be talking about positive values. Okay, so on your notes we have a point A here, and we have point B down here. In order to find the length, if you're given a number line like this and it's labeled, you can simply just count. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So the length of AB with the segment labeling would just be 8. It doesn't matter if I landed down here in the negatives or if it's down here in the positives. If you just count, it has to be length has to be positive. Okay, you can also do it if the number line's not actually just going by ones or whatever. The distance between any 2 points, x and y, is the absolute value of the difference of the coordinates. Absolute value means that the answer is going to be positive. So even if you subtract the numbers and you get a negative answer, absolute value means that it's positive. You're going to make the answer positive because distance has to be positive. There's no such thing as negative 3 inches. 3 inches is 3 inches, whether I go left, right, up, or down. 3 inches is 3 inches. So that's what absolute value means. It means make the answer positive. So on your number line, you have these points A and B labeled. So as you can see, this is clearly not, these dashes here are not going by ones. Okay, you cannot go from 2 to 20 with this few of dashes. So instead of counting, okay, you can always just take the difference. Difference in math means to subtract. So you're going to take your points, A minus B, or B minus A. So 20 or 2 minus 20 would give you negative 18. And then again, you're taking the absolute value. The absolute value means make the answer positive. So it would be positive 18. Or you could have done 20 minus 2, and you would have gotten positive 18 right off the bat. Okay, but absolute value means, it doesn't matter what order you subtract it in, absolute value means your distance is 18. Positive 18, negative 18, the distance is 18. Okay, so on example 3 here, okay, you can take A minus B, so negative 10 minus 10 would give you negative 20 as your answer. The absolute value, which is shown using these bars, would mean that instead of negative 20, your answer is positive 20. Again, negative 20 inches doesn't make any sense. Okay, all distance values have to be positive. Congruent is a vocab term, exactly equal in size and shape. Congruent sides or segments have the exact same length. Congruent angles have the exact same measure. For any set of congruent geometric figures, corresponding sides, angles, faces, etc. are congruent. Congruent means it's equal, same size, same shape. So the way that we say congruent, the symbol is an equal sign with a little squiggle above it. So I can say segment AB is congruent to segment BC using this symbol. The way that you mark it in a picture, I can say that AB is congruent to BC by using dashes. One dash would indicate those are congruent. If I added to this picture, I could mark these as being congruent by using 2 dashes. 1 dash will be congruent with 1 dash, 2 dashes will be congruent with 2 dash. Alright, the segment addition postulate. If points A, B, and C are on the same line with B, between A and C, then AB plus BC is equal to AC. So AB, this chunk here, added to BC, which would be this chunk here, would equal the whole thing, AC, which I feel like makes sense. If I take one piece and add the other piece, I get the whole thing. And that's all that this is saying. So if AB is 3 and BC is 5, then 3 plus 5 means the whole thing is 8. Okay, segment addition. I take two pieces of the segment and I add them together, I can get the whole segment. On the flip side, if I take the whole segment and subtract one piece, I can get one of the other smaller pieces. So in this example, it says if AB is 6 and BC is 7, what is AC? So AB, they're saying, is 6. So this chunk here is 6. They're saying that BC is 7. So from B to C, this chunk is 7. They're asking what the whole thing between A and C is. Okay, so the segment addition postulate says if I take the red chunk plus the blue chunk, I can get the whole segment. So 6 plus 7 would give me the entire chunk. 6 plus 7 is 13. So again, AB plus BC could give me the whole thing, AC, and AC is 13. Alright, in this example, DE is equal to 10, DF is equal to 15. What is EF? So go through and label your picture. DE from D to E here is 10. From D to F is 15. So that's not this little chunk here. Okay, D to F is the entire thing. From D all the way to F is actually 15. They're asking what is DE. They're asking for this blue chunk, EF. Okay, so again, this is a little bit different than the last problem. In the last problem, we took the red chunk plus the blue chunk and we got the whole thing. Now they're giving us the entire thing. So instead of adding up the two smaller pieces to get the biggest, the whole thing, you can take the whole thing and subtract one of the little pieces. So 15 minus 10 would leave us with 5, and that means that this chunk is 5. So the segment addition postulate, the opposite of addition is subtraction. So you can add them together and get the whole thing, or you can take the whole thing and subtract part of it to get the remaining part. So EF is 5. Alright, example 7. If AB is 2x and BC is x minus 8 and AC is 10, what is x? So you're still using the segment addition postulate, they're just not giving you numbers. Okay, we're going to write an equation and solve. So AB, this chunk here, is 2x. BC, which is this chunk here, is x minus 8. AC, from A all the way to C, the entire segment, is 10. They want us to solve for x. So we need to write an equation still using the idea that AB plus BC equals the whole thing, AC. We're still using that idea. So for AB, we're going to plug in 2x because that's what it is. We don't know the actual number value. BC is x minus 8 equal to AC, which is 10. If you solve this equation, you'll find x. Okay, 2x plus 1x is our like term, so that would give us 3x. Bring down your equal minus 8 equals 10. Add 8 to both sides. You always move your constant before your coefficient. So you'll get 3x equals 18. And then divide by 3. So x is 6. If they asked what AB and BC were, you could take X and plug it in here and figure out what those segment lengths are. Alright, if AB equals 3x minus 1 and BC equals 2x plus 1 and AC equals 20, again, what is X? So AB, this chunk here from A to B, is 3x minus 1. From B to C, they said was 2x plus 1. And AC from A all the way to C, they said was 20. Again, using the segment addition postulate, AB plus BC equals the whole segment AC. So AB was 3x minus 1 plus BC, which they said was 2x plus 1, equals AC, which they said was 20. If you solve this equation for x, you'll have x. So 3x and 2x are like terms. That would give me 5x's. Negative 1 plus 1 are like terms. Negative 1 plus 1 is 0. So those cross out. So 5x equals 20. I'm going to go ahead and write this over here so I can see it better. 5x equals 20. The opposite of multiply is divide. So I'll divide by 5. X is 4. Again, if they asked me what AB was, if I actually wanted to know what AB is, that would be equal to 3. Take x out and plug in 4 minus 1. So that would be 12 minus 1 is 11. If I actually wanted that length, they wanted to know what BC was, I could calculate that. Take 2 times 4 plus 1, which would be 8 plus 1, which would be 9. So again, if they asked me for the actual segment lengths, I would take x and plug it in.